Okay, good morning, guys. This week we start covering chapter 7. So we have only one more chapter to go, so we are almost there now. Since you know how to create functions, user-defined functions, now we need to look at how do we define our own data types. We're going to learn a little bit more about what namespaces are and how do we work with namespaces. And then we're gonna look at the string data type a little bit further and look into a little bit more details on how do we manipulate strings. Okay, so in this case, we're going to start with the enumeration type, and the enumeration type is an integral type of a data type, but you will define it, and we'll talk about why would you use that. How do we work with that in something like for loops? Later on, we'll talk about typedef statement. Now, the typedef statement, think about it like a shortcut. So if you want to launch an application, let's say notepad.exe, and notepad.exe is in C/Windows directory, then you would always have to go to the directory, double-click on the executable, and launch it that way. But why not just put a shortcut on the desktop so you can just launch it from a desktop? So the shortcut is just a representation of the real executable. So we're going to be using typedef as a representation for something, a data type that already exists. And you've been using the namespace std throughout this whole semester. And we mentioned certain things about the namespace, but here we're going to learn a little bit more. Why do we need the namespace? And then we're going to close the chapter by talking about string manipulation. So the enumeration type is what we're going to use in order to create our own data types. And so what is a data type? A data type is just a set of values with a set of operations on those values. So enumeration type is a simple data type that is created by you, the programmer. And it can be used in your program. To define an enumeration type, we'll need a name for the data type, a set of values for the data type, and the set of operations on those values. As I'm going through all these chapters or these slides, if you have any kind of a question, make sure that you type it in or click on the talk button and use your microphone to interrupt me anytime if you have any kind of a question about this chapter or prior chapters or any kind of a assignment type of a questions. So the enumeration type has its rule. It has a rule set, and one of the rule set is that the values have to be in a ordered sequence. So in the ordered sequence, value 1 is less than value 2, and value 2 is less than value 3. And that's pretty much what the rule is. Beside that, the values, see the value 1, value 2, which is the parameters, you can see that those are really identifiers. So those identifiers or enumerators are going to follow the rules for any other identifiers that we used so far. So we need to use the keyword enum for the enumeration type, and then give it a name. Give it any kind of a name. Again, follow the identifier naming standard, and then we need to list the enumerators. So the enumerator type is an ordered set of values. The default value assigned to the enumerators start at 0. A value used in one enumeration type cannot be used in another enumeration type if they are both in the same block. So same rules apply to enumeration types declared outside of any blocks, which is the global enumeration types. Okay. So now you can see that there is a data type that is called colors, and the colors can only take up values of brown, blue, red, green, and yellow. Now later on you can also use this to validate the values that can be assigned to colors. Because right now, if somebody going to assign black to colors, that's going to basically create a compiler error saying that black is not a valid color. And same thing with, let's say, white. If you try to assign white, white is not in this list. So in order for colors to take up the value of white, you would have to add white to the enumeration list. So same thing with the second example. When you look at the standing, okay, you only have freshman, sophomore, junior, and senior. So you only have 4 values that can be assigned. But by default, these are integer values, right? So make sure that you understand that by default, brown is going to be 0, blue is 1, red is 2, green is 3, and then 4 going to be yellow. So here with standing, again, it starts at 0, then 1, then 2, and then 3. Now, you can see that these values are in an ordered set with increasing values. So this is basically an ascending order of integers. And after we declare this, we cannot change it. So the best way that you can look at this is maybe you would think about it as const integer, and then let's say brown, see, all capital, and equals 0. And then you might say the next would be const int blue equals 1, const int red equals 2, const int green equals 3, const int yellow equals 4. You see, like, this is kind of like annoying, isn't it? That you have to write all these constant values. So instead of that, you're really combining all these constant values, and you're just going to call it colors, right? So that's what the enumeration type is. It's really just make sure that you understand that this has to be in a ordered list. But really it's just a list of constant values. And really there's nothing else to enumeration type. Okay. So now you can see here we have some problem with the enumeration type because the enumeration list has the singletons, And just like we said, the enumeration values, these going to have to follow the identifier rules. So just like I showed you before, these are really just values that we don't ever change. So these are just identifiers. So you can see here's the problem, that we start the identifier with a number. That's not allowed. Okay, and then if these two enumeration types are in the same block, right, we cannot use John in two different enumeration types. So there are some rules that you need to remember when you're using it, but beside that, it's pretty straightforward. So how do we declare variables? Well, if we have the enumeration type of sports, think about it just like if this would be an integer or a floating point or a character, right? Now, the data type becomes your enumeration type. Right? So this becomes now your data type. That's why it's called a user-defined data type, because you created this. Sport is the data type. And then you have, think about it like, this is X, and then you have Y, and end of the statement. So you could have said integer X comma Y, okay, where integer is the data type. But now sports is the data type. And you have many different sports, popular sports and my sports. But here we're gonna make sure that if you're talking about popular sports, they're gonna have popular sports. You're gonna only consider 6 of the values. So when somebody says, what is my favorite sport, or my sport, you also have to pick from this 6, the list of 6. So it's gonna be great for validation. Okay. So how do we assign values? So we declare them just like any other data type, and now we have a identifier, and that identifier we can assign to a value, and that value has to come from the list of values defined in the enumeration type. Now remember what a data type is. A data type is a set of values and a set of operations on those values. Now how do we operate? Now, we cannot just use the plus and minus signs. We cannot use just a simple assignment operator, because those operators are also functions. So when somebody writes a function, let's say the equal sign needs 2 operands, right? It's a binary operator. So something on the left side and something on the right side of the operator. But that person does have no clue that you have a data type called sports. So if the person does not have a clue that you created a data type called sports, they cannot create a function that will take data type sports. So there are some operators that you cannot just use just because you would like to use those data types. Okay. So the one thing that we can do is we can force the data type into its real data type, which is integer. Right? Now in this case, popular sports is a data type that is a lot of integral values. Right? So depending what the popular sport is, it's either going to be 0, 1, 2, 3, 4, 5, right? The 6 values in the popular sport. Those are really integral data types. So now we can add a value to it. Now because it's an integer, we can use the plus operator, because we know how to add. Let's say if the popular sport is 3, we know how to add 3 plus 1 together. But that's going to be an integer. We don't want the integer. What we want is to cast it to the data type sports. So you do the arithmetic operation, and then at the last step, you're casting it to the sports, which is the actual data type for that integral value. So that's how we go around the operator limitation. Now, if you look at, okay, so we have basketball, football, hockey, baseball, soccer, and volleyball. So when we look at it, football is less than soccer is true. So why is football less than or equal to soccer? Well, because football is right here, so will represent 1, and soccer is right here. It really represents 0, 1, 2, 3, so it's going to be 4. So when you're saying football less than or equal to soccer, the relational operator can actually work with that, because now it is referring to integers. So hockey is greater than basketball. Why is that? Hockey is 2. Basketball is 0. So really what we're doing is 3 greater than 0. And that is true. Baseball is less than football. Baseball is less than football. Well, let's see. Baseball is 3. Football is 1. So you're saying 3 is less than 1. No, I don't think so. That is false. That is a false statement right here. Okay? So you cannot really find out how these comparisons are made unless you have access to the enumeration type declaration and find out what are the proper values. Now, when we're using it in the for loop, right? So we have my sports, and the my sport needs to be initialized. So when my sport is initialized, let's say to basketball, okay, you need to see that that is really you initializing it to 0. Okay. So my sport equals basketball. It's really like if you would say int x equals 0. Right? So then you're comparing what? You're comparing 0 in this case, less than or equal to soccer. Now, what is soccer? Soccer is 4. So you're comparing that to 4. Okay. And then what my sport contains, you add 1 to it. Now, how do you do that? Now, here you need to make sure that you have the assignment operator, right? We need to make sure we go to the next value in my sport. The next value in my sport is 0 plus 1. Now 0 plus 1 is 1. Casting at the sports, we look at it, what is 1? 1 is going to be football. Okay. So that's where you can see it works exactly the same way like any other for loop. Okay, but instead of saying my sport equals 0, which doesn't really mean anything to me as a programmer, I'm not really sure what you're comparing when you're comparing 0 less than or equal to 4. So in this case, you can see that if we give it some words, okay, then it's easier for somebody maintaining my code to interpret what I was writing. So I started at basketball, and I go all the way to soccer. Now, an enumeration type cannot be input or output directly. So what we need to do is we need to convert the enumeration type and use a different structure in order to display something or assign a particular value. So the CIN, cout operator, doesn't know how to display these values, so we need to force it to display or show values or process values entered by users in a way that the users can understand it. Okay, so in this case, algebra is really 0, right? So if I want to print out algebra, cout registered, it's gonna output 0. So if you output 0, you have no clue. The user, when he looks at the screen, is like, what is 0? I don't know what 0 is. Okay, so what you can do is you can take that algebra, put it in a switch statement. We'll be sending in the variable, right? The variable is registered. Registered data type is courses. Courses is an enumeration type, which is an integer. So since it is an integral data type, switch can work with that. And then you find out that the registered equals to algebra. Algebra is, in our case, is 0. So with case 0, you're not printing out 0. What you're printing out is algebra. So that's how we helping the user see what the user is working with on the screen. But inside our program, we use enumeration type that is really not going to help the user itself. Okay, it's not going to help the user experience or the interface, what we show to the user. That's not our goal. Our goal is to make the program, the source code, easier to understand. And that's why we use enumeration type. Functions, enumeration types can be passed as parameters to functions, either by value or by reference. So that's going to be useful. And the function can return a value of the enumeration type. So just because we created this enumeration type, that means we can still work with those data types, just like with any other data type that we have available, like say like integer and floating point. Okay, we have to specify what value represents each course is when we ask for input. No, we don't specify that. That's a good question. That see, when you have an input, okay, in the input, if let's say the user types in algebra, right? Now with the algebra, we have to. It's gonna be basically the same thing. We cannot use it in a switch statement because when we read it from the user input, it's going to be a string data type. And you know that we're not going to have a string data type. But we cannot use string data type in the switch statement, right? So then we can say if, let's say, answer, right? If answer is algebra, which is coming from the user, right? Then what we're gonna do is, let's say, registered equals, right? And then we're gonna do static cast. Now what is it we want to cast it to? Well, we want to cast it to courses. Okay? And in this case, let's say it's going to be just 0. Okay, so as far as we are concerned in a program, you might look at enumeration type creates a little bit more work than not using enumeration type and just say, well, the registered equals algebra, and that way you just set registered as a string, right? If that would be a string, you could directly say CIN registered, and then that would equal registered to algebra. You might see it as much easier, but that's not our goal. Our goal here is, you see, 0 might mean algebra in this application or in this program, but maybe in another program algebra would be 5. So that means if you would have a program that would work with just literal numbers, okay, it would be really confusing to figure out what string means what value. So so programmers would have a hard time. It would be more difficult, and it would be harder to debug somebody's mistake, somebody's code. But if I look at it and say, okay, algebra is 0, then I know where you made a mistake. Right? So it is just one of those tool sets that we can use in our tool bag in order to program, and when somebody else reads it, then it's going to make more sense to that other person. Okay, and keep typing in questions if you have some more, or if it doesn't make sense, then I can spend a little more time on it, or maybe next time we can also spend a little bit more time with this. So enumeration types can be passed as parameters to function either by value or by reference. So we're using the enumeration type just like we use any other data types. We can declare variables of an enumeration type when we define enumeration type itself. So here we're still going to have course grade is going to be our variable of the type grades. Where course grade is a data type of grades, and grades can only take up either one of these values, A, B, C, D, or F. But we're doing it at the same time when we're declaring it, and we initializing or declaring the enumeration type, and also declare the identifier. And because of that, that capability, that we can have the identifier declared, okay, and now you can see that, okay, what comes over here? Well, there is no name to it, okay. So if there is no name to it, okay, how do we create that data type? Well, we really don't. And that's the value of this, that like I said, if these are all the basketball, football, baseball, and hockey, you just really want to use them as constants in one big group, then you don't want to create a data type, okay? What you want to use is just, you know what, my sport contains all these different constant values, and I don't allow for any other sports to be listed but these 4 sports. Then you declare it as you define your data type at the same time, so later on you don't have a chance to declare a new identifier of this particular data type. But of course, it also comes with some strange effects. So it's also going to have like a positive and negative effects, right? So the drawback is it cannot be passed or return any anonymous type to or from a function. So now you have constant values that you cannot really send to functions. So if you want to use these constant values locally, it's perfectly fine, but you cannot use them in other functions. So if we cannot use them in functions, what can we use? Well, we could use them as a global variable, right? A global data type. So we don't need to send them and receive them from functions. We can just use them. Values used in one value can be used in another, but are treated differently. So it can be kind of strange and a little bit confusing when you're using French and what data type is French. Well, I don't know. And you cannot use the assignment operator just to assign one data type to another data type when it's anonymous type. So best practices to avoid confusion: define an enumeration type first and then declare variables. So that way you're going to have to give it a name, and try to avoid using anonymous data types altogether if you don't have to. Okay, so now we're moving into a type def. So in type def, the main thing is the keyword is type def, and then we have an existing type, and then we have a new type. So let's say you want to create a data type, and let's say the data type is unsigned integer, and you're going to say unsigned integer x equals to, let's say, 5. Right? You see this existing type, unsigned int. It's kind of long and it's hard to type, or it takes a little bit longer to type. Maybe I have to use a lot of unsigned int in my program. Yeah, but maybe I work for Richland College. Okay, so it would be much better if I say type def, because I work for this company that's really using unsigned integers a lot. Then we can say type def. What is the existing one? Unsigned int, and I want to call it RLC. Now I can just say RLC x equals 5. And now that RLC will really refer to unsigned integers. So the type def, that's why I said that the type def, just think about it like a shortcut. It's just an easier way to refer to something that might be really long, and it might be really hard to type or hard to interpret. Of course, right now we're just in the beginning level course, and right now you might say that's pretty easy to remember. Why would I do that? Well, C++ is not that simple when you go into a higher or a more advanced level. So at this point, just kind of think about it, or take it for granted that if something is really complex, we can refer to that in a simpler manner. And even if we don't see it right now, at least we know that it can be done. So what about namespaces? When you look at the namespace, think about namespaces as a room or a house, right? So let's say John lives in a house. Well, how many Johns are there? Well, there's a lot of Johns. So you need to refer to the house that John lives in, and then the member of that house, which is John. And this way, if you yell out John, you will know exactly which house to look into and not just gather everybody. Remember, computers don't really like dubious statements. Computers are not really good at deciding which one to pick. They like to follow a rule. So global identifiers in a header file used in a program become global in the program. So you can have a lot of header files that use the, let's say, the identifier size. So if you include all those header files into your program, how do you know which size you want to use? They're going to be conflicting with each other. So syntax error occurs if a program's identifier has same name as a global identifier in the header file. So if you're creating a global identifier in your code, and that code also exists, or that identifier exists in a header file, you're going to have a syntax error. So same thing can happen with third-party libraries. So what we do, and that's what we said in the beginning of the semester, we talked about that identifiers follow rules. And we said about the characters can be used, the numbers, underscore character can be used in identifiers, but by convention, even though it's allowed to use underscore, we don't ever use that to begin our identifiers. It cannot really be enforced, but what we do is we are, by convention, we never start our identifiers with an underscore. So this way, third-party vendors, or those who maintain the actual programming language, can use in their identifiers and start their identifiers with an underscore. So that way we never conflict with each other. So, but it is just really a convention. So when we're talking about standardization of a language, and it was, C++ been around for a long time, but it hasn't been standardized that long. That was only standardized in the early 90s. And that's where standardization comes in place. When why would you need standards? Well, because there used to be a lot of problems, global identifiers conflicting with each other. But the ISO standard came up with this namespace that allows you to put your global identifiers in rooms. And because they are in rooms, now we can refer to each identifier separately. Inside the namespace, we can have variable declarations, name constants, functions, or other namespaces. So we can have nested namespaces. So you can see in this particular case, right? So if we use this in our code, okay, let's say you have your program, and your program gonna have, let's say, int main, and then we have our block, okay. And inside your main, let's say you have constant int n equals, let's say, 15. And then you're going to see out n. Now, what's going to be printed out? And so what is going to be printed out when you run this? Well, what's going to print out is 15. Why is it 15? Because n, without specifying the namespace, will look at the identifier closest to that statement. So what's closest to it is N inside main. Now if we want to print out the global type, then we can say cout, and we can say global type colon. Now that's going to be a scope resolution operator, right? And with this scope resolution operator, we can say I mean N, capital N, that is in the global type namespace. So in that case, what we're going to print out is 10. Now, if let's say we have a const int n equals, let's say, 20. Okay, now this is outside main and outside any function. So what is that? That's going to be a global identifier. Right? Okay, a global identifier that is not in any namespace. So how can we print that one out? Okay, so if you do cout, what we can do is just the colon that has no namespace in front of it, and then we print out n, then we're going to print out 20. Okay, so the colon without a namespace is the global identifier. If you do have a global identifier with a identifier that you need to access, then you can use the scope resolution operator and then just name the namespace in front of it. Okay? And that's what I mean, like, think about this like a hallway, right? So we have this hallway, and on the hallway we have different rooms. Okay, maybe this is called the A room and this is called the B room. A room has X and B room has X, and the hallway has X. Okay, so the hallway is the global identifier, right? How do we access that? We would access that just with the colon in our code. If we want to access X in B, then we would put in the namespace, or think about it like a room number, and then colon and the X, which is the variable name. Okay. Now, if we need to access X in A, then we say room number colon X. So this way we can have X in 3 different places, and they're never going to conflict with each other. So X global, XB, XA, they can be happily reside in those rooms, and they're never going to conflict with each other. When we code, we just need to know exactly which variable we want to specify. Okay. So it's pretty straightforward. It makes our life much easier. Okay. So the namespace member has scope local to the namespace, and that's why, because the scope is local, it's not going to conflict with anything outside of that scope. That just means if you are in the room, if somebody calls your name, it doesn't matter if somebody with the same name sitting in another room, you will know that whoever called your name, they called you, because you only hear that call inside that room. So if you want to use the namespace, just like we did with the cout, right? So if you have, let's say you're saying you have a namespace called type, and within type you have X, and it's kind of annoying to type in type colon. Remember what we did, the std : CN. Let's say we're reading into X. We're trying to say CN is in this namespace, and I think it's annoying to use that. So what did we do? We did using namespace. Right? So we did the keyword using and namespace, and then we did std. And after that, we did not have to use this std because CN is in std, and we told the code that every time I say CIN in the std room. But you can have multiple namespaces listed. So you can have using namespace, let's say type, and then using namespace std. So we can still have those. Now the only problem is, okay, if for some reason std has an X in it and type has an X in it, now the computer is still going to give you a syntax error because now it's dubious. I don't know which one you want me to use. If you know that the namespace does not contain the same variable names, then you can safely use it by just saying using namespace, and whatever is defined outside your code, it will look into the type namespace and then into the std namespace to find the actual identifier, even if it's not declared within locally in your own code. So it makes it much easier, again, to use. And again, it's not for the users, it's for other programmers, it's for us. Okay. So when you're using global identifiers, you can use global identifiers, but if for some reason you really would like to use rate, okay, and whatever header file, whatever library that you include, your compiler will tell you that you don't want to find out or go into every single library to figure it out, right? You're just using it, and then you're going to see a compiler error message. And the error message says, hey, you are conflicting with this library's identifier. That when you are writing yours, then you can create a namespace in your code and put all your identifiers into that namespace. And that way you can avoid conflicting with anybody else's library. After the using statement, it is not necessary to put the namespace colon before the namespace member, unless the namespace member and the global identifier or a block identifier have the same name. Okay, so if you get an error message, resolve the error message by telling your code exactly which room your identifier is in. And you don't want to mess with somebody else's code. You want to fix your identifier. Right? So if you really want to use rate, don't go into other people's source code and change theirs. Okay, make sure that you pick something else. Okay, so if rate, you like the rate as an identifier, maybe call it my rate, just to make it unique. Okay, so when it comes to the last portion of this chapter, okay, and this is what I want to focus on more on Wednesday, the second time that we're going to be focusing on this chapter. Okay, we're going to go a lot more deep details, and we're going to look at more of the code, how to use the enumeration type, how to use the type def statements, and all these. Okay, so we're going to be spending a lot more time next time on actual code and how to use any examples in this chapter 7. And I'm going to give you, we're going to go through a lot more extensive examples using the string type. Okay, but it's going to be very important that you guys are going to be comfortable with the debugger and stopping the code, so we can actually look at a lot of different values. So I really want you to run the sample code that comes with your book, okay, referring to this chapter in chapter 7. Run the code and put in as many breakpoints as you can. So we can talk about it next time if something doesn't make sense. Okay, so what if we want to update the value of the global identifier? Well, you would do the same thing, right? I mean, let's say here we want to update, let's say X, right? Then you would say type : X equals, let's say 5, right? So nothing changes at all. Okay, you just have to tell exactly which one, which identifier you want to change. So let's say if std and type, both of them have X as an identifier, you cannot just say X equals 5. If you're using the statements, right? Because the compiler have no clue which X you want to assign the number 5 to. Okay, so if you have X in type, then you would have to, okay, put in the namespace. If you would have X in std, you would have std : X equals 15. Okay, so don't get confused. Everything is the same. This is not an enumeration type. Okay, so this is not how we started. That with enumeration types, we cannot just use any arithmetic operators. Here we're still using everything just like we used before, but we want to avoid any kind of a confusion. And if there is something confusing, we can put in a scope resolution operator to tell you exactly which room value you want to update. Now, if you do not have X in both of them, type and std namespaces, then you can just use X equals, let's say, 20. Because if, let's say, type has X and nobody else, no other global identifier exists as X, then the compiler will know exactly that X in type needs to be updated. But because you're using the statement using, okay, it knows what rooms are available. So it will have no problem finding the right X. Okay. So when we're talking about a string type, we need to work with string header file. So we need to include the preprocessor, and we need to have the string library added to our program. Now, string is an array of characters. First character is at position 0, and the second character is at position 1, and keep increasing the actual index value. So we're gonna be calling that the index value. Next chapter we're gonna be talking about arrays. Okay. So if we have, let's say, string name equals, and let's just say RLC, okay, then when you say cout name, and then we can look at the index value, we can say index 1, but that's going to print out is L. Okay, because when you have a string, okay, you need to think about the string just like in chapter 3. We were talking about output manipulation, right? When we were looking at output manipulation, we were looking at characters on the screen, laid out in a matrix, and the matrix was numbered, right? So we have the first one, second one, and the third one. The index starts at 0. So a string is an array, a list of characters. So the first, the character R is stored in index 0. Character L is stored in index 1. Character C is stored in index C. So later on, when we'll learn about arrays, we can have this subscript, this index value, and that's going to refer to that index value, which is really not stored as an index value. It's just the location of characters in the string. Then we're going to be able to refer to each one of those characters. Now, when we're talking about operators on this data type, okay, plus sign is not an addition operator. Okay, when it comes to strings, the plus sign performs a concatenation of strings, so it adds the strings together. The array subscript operator, which is the square brackets, allows access to an individual character in a string. Okay, so you can see that string also has its own namespace, and within the namespace we have a size underscore type, which is an unsigned integer. Unsigned integer. Well, so how come we're not just going to say unsigned integer? Well, unsigned integer is going to be basically a type def, right? A type def that is referring to, okay, referring to an unsigned integer by the name size type. So really, if you want to, and you want to say unsigned integer x equals 15, okay, you could also say string colon size type x equals 15. It's exactly the same thing. Okay, and then we have the end position. Okay, the end position is the value of the type, a number that tells you what is the maximum number it can represent. Okay, so that would work as well. And then there's a lot of different functions. So we're going to be talking about what do you mean by functions? Functions going to use the member access operator. So if this is a member access operator, okay, we use the single period. Okay, so string going to be this big box. Okay, so this is string. Okay. Inside that big box, we're going to have a word, let's say warm. Okay. A string is a data type. What do we know about data type? Data types are values and operations. Now, one of the operations we can perform on string is swap. Okay. So you can see swap itself has a name swap, and then it has the string 2. String 2 going to have the string that we want to swap with. Okay. So we're sending this string object another word, which is cold. Okay. We replace this, so we're going to get rid of warm. We're going to have cold, and then we're sending back to the identifier, which is string 2. String 2 going to be warm after the fact, right? So wherever that warm is in memory, now we refer to that string as string 2, and this box is string 1. So what do you think about this string 2? Well, seems like string 2 is really a reference parameter, right? What do you mean by reference parameter? When we are inside this box where warm was stored originally, and we make the swap, because we are referring back, we are referring to the reference of string 2. We can make changes to that string 2 because we know the memory location where string 2 resides. And that's why it's very important to cover the previous chapter. If the previous chapter makes more sense, this chapter also going to make sense, because you're going to look at the functions and you will understand why are we going to change the value of string 2. Well, because string 2 is a reference variable, so within the function we can make changes to that reference variable. Okay, so make sure that you run the sample code in this chapter, and bring questions next time. And next time we're gonna only talk about the compiler, the IDE, and how to run all this code, how to use the debugger, how to look at each one of the characters in string, and best practices, how to study, how to learn this particular chapter. Okay, so I'll see you guys next time, and make sure you bring some questions.